So I'm an application here at Javelin Technologies, and I work on the 3D printing team. So my job is to highlight new software developments and new technologies and find the best place for the fit and function for 3D printing, either in our customer base or in potential new customers. And where I'd like to go today is I want to highlight all of the new features for 3D printing within SOLIDWORKS 2017. They've done a really good job at wrapping it up into one tight-knit package, and it's under one tab called 3D Print. And I'll take you through it a little bit later in a demo, but for the first little while, I just want to jump into what we're going to be covering. So for those who are not familiar with Javelin, we are a nationwide company. We first originated 19 years or so ago in CAD and specifically SOLIDWORKS. And now we've branched off into other 3D solutions. So we're mainly in SOLIDWORKS as well as 3D printing. But as you can see, our head office is here in Oakville. And then we have offices from Dartmouth, Vancouver. Brand spanking new office in Vancouver we're all very excited about. So to give you an idea of where we fit into your company, we try to focus as much as possible on the people, technology, process, and manufacturing. What does that mean? Well, a huge portfolio of ours is training facilities and training services. We want to make sure that your employees are as trained and up to speed on 3D technology as possible. So we really emphasize that we want to get your people inside your company as comfortable with our technology as possible, and we provide a range of services for that. The technology aspect is going to be mainly 3D CAD from SOLIDWORKS as well as 3D printers from Stratasys. Now, we focus on those two companies because we truly believe that they're forefront in their respective industries, and we find that they're pushing the envelope of what's possible. We like to help companies with their process as well. We find that there is a lot to be gained with some process refinement, and Javelin has some excellent services to do so, as well as manufacturing support, launch, ramp up, production, as well as phase out of old technology, and then get some new ideas and concepts flowing again to complete that product's life cycle. So today, what I'm going to be going over in the next couple of minutes, it's an introduction to SOLIDWORKS 2017 3D print features. And I'm going to highlight the print orientation and prep, the layer height selection and layer visualization, as well as the thin wall detection and gap detection. If we have time, we'll jump into GrabCAD print. If not, I'll just briefly touch on it by talking about some of the highlights. But why does it matter that SOLIDWORKS is venturing into the 3D print features? We're not trying to replace the current softwares that print parts from the machines. Where SOLIDWORKS is really trying to get into, they're trying to make sure that when you design a part in CAD, you stay in the same software, which we trust, SOLIDWORKS. We know that the check fixtures are fantastic in it. And we want to make sure that when you finish designing or you're partially finished designing a product, you can immediately check what it's going to react well with 3D printers. So the idea is a one-stop shop for not only design, but print preparation as well. And we'll touch on the features going forward. And ultimately what we're trying to do is it enables CAD and print designing in parallel rather than in succession. Before, what would happen is people who are not as familiar with 3D printing, it's hard to conceptualize how layer lines affect builds and what does the orientation mean about this assembly that we're going to be printing. And for a conventional designer, it's not always easy to visualize that. So SOLIDWORKS has made a big leap forward in 2017 to get that visualization. Now, the idea is to reduce or eliminate STL files. I'm not sure if you guys are aware, but STL files are the major source for errors within 3D printing. And for those who are also not familiar with an STL file, what it does, if you have a solid body in a part from SOLIDWORKS, it's going to triangulate all of the surfaces of that part so that the printers can then read where the boundaries between the part and air is, so it knows where to put the material. If you imagine an STL file, imagine it as a three-dimensional PDF for 3D printers. It's the printable file format. Now, SOLIDWORKS and Stratasys are working very hard to eliminate the STL file because what it is, anytime you save out a file, there's a possibility for error to arise. So we're trying to reduce or eliminate that. We're also trying to reduce the management of files and allow for easier workflow. For those who have printed, you'll know that when you start to save out STL files, you'll end up having versions 1, 2, 3, 4, and 5 all in the same file format, it looks messy when you're trying to keep organized. So it's just another way that you don't end up printing the wrong file by mistake, is always using the native CAD files. The last thing it's trying to do, SOLIDWORKS really wants to make sure that you stay in-house with SOLIDWORKS, because you're going to ultimately end up trusting the SOLIDWORKS developers to develop a fantastic product. From my own experience working in the field, I've found that third-party STL softwares, however they may be excellent at what they do, they're not always as reliable as you may want. So I have found SOLIDWORKS to be a much more reliable software to work with on a day-to-day basis. Whereas the open STL softwares, they might work for one or two features, but they're not going to do a great job at checking gaps or thin walls on a consistent basis. The next thing this SOLIDWORKS 3D print is ideal for is scaling models. If you were to think about the architectural industry, you're working with very large job sites, and what happens is with the large job sites, when you scale them down to print, you're going to have very thin walls, because a wall that might have started off being 18-24 inches wide is going to end up being essentially 0.5 millimeter, 0.1 millimeters thick when you scale it down by 1% or down to 1%. The issue with that in 3D printing is the printers themselves and the software will not throw any error codes or any notifications that your build won't build successfully. So what might happen is your thin walls might vanish according to the printers, because they are just too thin to print. There's just not enough material there to deposit. So what that's going to do is you might end up with parts after a 24-hour build that have none of the internal walls that you want on them. So the thin wall feature detection in the SOLIDWORKS 17 3D print features is a fantastic tool going forward. Now, it's a prime candidate for architectural and site planning. However, if you were to think about any scaled models, it works just as well. Now, the last thing it's going to do is allow you to preview your files to ensure the best printing practices. And it'll make more sense when we get a visual representation of this. But what it is it'll allow you to visualize and show in SOLIDWORKS the layer lines you're going to get with FDM style printers. So let's jump into a couple things. So this is the traditional 3D printing process. Originally, you're going to design your file in either SOLIDWORKS or another CAD software, and you're going to have a fantastic part ready to rock. Then you're going to have to file save as your STL file, and as I mentioned earlier, it's a very prone source for errors. From your STL file, you can then send it to the printer. But notice in this workflow, you cannot send your CAD files to the printer itself. So having that intermediary step is just opening the door for errors. Whereas the new 3D printing process is going to go from your CAD file directly to your printer. And SOLIDWORKS is just another feature to make sure that your files are exactly what you want before you print them. So allow me to switch over to SOLIDWORKS, and I'll show you the new features and where it's going. Apologize if my computer seems a bit slow. So this is a feature I designed, and what it is, it's a check feature for a shop floor. It's going to be made out of very tough and industrial engineering grade plastics from our Fortis machines, and it's going to probably see a nest, and it's going to nest components for about 400 or 500 components, and then it may be swapped out, or the run of the production might be finished. Now, I've gone ahead and designed this as solid bodies, not surfaces, because remember, 3D printing, you always want to work in solid bodies. And that's because the printers can read solid bodies. They have a hard time reading surfaces that are knitted together. So that's one critical feature here, that this is one solid body. Now, if I wanted to go ahead and get this to printer today, I'd have to save it as a STL. It's going to triangulate every single face here. It's going to be quite the nightmare. Whereas now what I can do is I can go to this trusty print 3D feature, or in the search option, I can just go 3D print, and you'll see this little drop down. And it says print on a local printer. You can set it up to your local printers. What I've been using it more as a check feature than anything else. So let's go ahead and enter that. I've got a shortcut key here. Let's see if it actually works. Okay, so we're now in the print 3D, and as you can see, here is our representation of our build envelope. So we've got our building platform here, which you can change. So if your printer does not come up locally, you can customize the build envelope here. So if we were to change the depth to 254 to make this more of a square build print, you can see that that is the build envelope. Now, as we scroll down the feature tree here, what you have, which is very handy, is your print bed location. So if I go ahead and click one of these faces, that will align it to the bottom of the print tray. So if you're looking from a bird's eye view, that build envelope there, right here, this XY plane, that's the feature I'm going to locate this surface to here, and it should stand on end when it's ready to go. So let's go here. It's okay. And then we can also rotate the model as we see fit. A really handy guide is that Orient to Fit button. If the model itself is larger than it needs be, let's say it's 2 times the size. Do you see here how the colors have changed? What that is essentially showing you is that this component is now outside the build envelope and your part no longer fits, so it won't be printable. Now you can do a couple things. One is you can redesign your file, go back in, cut off some corners and bring it back into 3D print, or you can go ahead and scale. Now you can scale to any size you want, but one of the best features here is the scale to fit. With this orientation, I can quickly hit that scale to fit, and it's going to automatically size it down, and now notice the print itself has just been enclosed by the print envelope and it will have a successful build. Now I do realize that this will change the geometry and the size and the dimensions of the components, but if you're not worried about assemblies or check fixtures and you just want a component to hold in your hands, it's a very quick tool to get that part to fit into the build envelope. Here we have options for draft, medium, and high, and what that is, when we'll zoom in, if we go for draft, medium, or high quality, and then infill percentage, it just gives you an idea of the precision that it's going to use to measure everything. So you can include supports or not, and you can include rafts or not. That's another option, but that's more so for the internal features. So your supports, if you imagine the printer using 2 materials, one is going to be model material and one is going to be support material. The way it works is the printer will print all up here in support material as a pedestal. So anywhere there's an overhang or an overlapping feature, it's going to print support material up to that component, and then it will build model on top of that. It's very similar to building scaffolding up to the material itself that it needs to build. So let's go ahead and dive into this a little bit more, and let's go into our next tab here, which is the preview. So you can look a little bit closer, and these are the actual build layers you're going to get on an FDM printer. Technically on any printer currently on the market, you're always going to have layer lines, and the reason is you're going to be building materials layer by layer, so you're always going to have distinct layer lines. Now the layer heights can change. You can go thicker layers, we can even go thicker than that, 0.75 of a mil. And as you can see, there's less layers with more roads, and this is going to become coarser. So because this surface finish here is on an angle, you're going to get that zippery or stepped effect. And so what you can start to decide, if you have the choice between, let's say, 10 and 20 millimeter layer heights, let's look at what 20 millimeter looks like. It looks pretty good, and you'll probably be able to sand that off to make it smooth. But if you had the option on your printer and you wanted to check what it would look like in 10 millimeters before printing the component, the surface finish is significantly improved here by just changing the layer height. And instead of learning the hard way of building a component and realizing it's the wrong layer height, you can just quickly change that. So if I change it back to 20 mil or 0.2 of a millimeter, you can see there's a significant difference there. So let's change that. We can also change the way it looks visually. So if we wanted to take the color away from the model and make it look a little bit more distinct for the layer lines, we can turn that off and it will turn into that zebra pattern we're used to in SOLIDWORKS. It's a little bit different than the zebra pattern, but it is quite similar in the sense of the colors and the textures. So the next feature I'd like to show is going to be this thickness and gap analysis. As we were talking about earlier, we were talking about the thin walls of architectural models. This is very critical, and if you see here, there is a thin wall component right there, and it's a bridge. So let's just see what that wall, how thick it is. So right now at the size of the model, it's going to be quite a thick wall. But if we go ahead and shrink this down, as if we were pretending to scale down a model house, let's say to 0.5. It's a very small model all of a sudden. What we can do is we can actually look and say, I know my printer cannot build anything thinner than 0.5 of a millimeter. And for those who don't know, the reason for that is the printer itself, if it has a nozzle on an FDM printer, it's like a hot glue gun. And if you think about the diameter of that glue gun tip, a thin wall needs 2 passes in thickness. So thin walls need to be at least a certain or a minimum thickness, and if they're not, they won't build correctly and they could fail or they could fall over or they'll warp just because there's not enough material support under the load. So what we can do here is use this thickness and gap analysis. Now we've chosen the ABS material, and let's just start to see where we get issues. So as I increase this thickness and gap number integer here, what it's doing is it's increasing the threshold. So if I put in 2 millimeters into this option, what it's looking for is any thin wall that is less than 2 millimeters in thickness. So ideally, at 0.5, do we have any thin walls? Because I know for myself, the printer I have in-house of our Uprint or Fortis machines, this is the thinnest wall we can print. Yes, there are a couple thin walls here, and you can see here in the legends, the orange color, or gold, as if you will, is a thin wall, and the blue is going to be a gap detection. So we'll touch on that in a minute. So one of the rivets here, or sorry, the rounds, is actually causing an issue. So it's telling me that those 2 areas here and here actually have thin walls that are less than 0.5 millimeters. And to be honest, from my trained eye, I would have never been able to tell that unless I brought out some calipers. So having this feature is going to save a lot of failed prints if you're working with smaller models. Now let's just exaggerate this a bit. Let's see if we can find any thin walls under 2 millimeters. So we'll zoom out to get a better visualization. Here we go. So we do have a couple thin walls that are less than 2 millimeters. And so what these lines are telling us is the distance here, that is going to be less than 2 millimeters. So this gives you a good idea of how this software can help you check your prints before building. And what it's going to do, it's going to it's going to streamline your process. B, it's going to allow you to save quite a bit of time and money. And C, it's going to reduce those headaches that you get after a build, which can be very costly if customer meetings are coming up. So those are all the features I'm going to go over to today. Actually, there's one more thing here. Let's see. No, I think that's all I'm going to go over today. So when I'm done evaluating the model, I can either check, yes, I've said everything's okay, and I've checked it. And so what it should do, if my computer doesn't crash on me here, what it should do, it'll bring me right back to the CAD file. So what I've noticed is with my daily work, I trust SOLIDWORKS much more than I trust third-party open source softwares that are free. And so if I have the option between choosing SOLIDWORKS to check my 3D prints or a third-party software, I'm always going to pick SOLIDWORKS just because of that trust. The other thing it does, it keeps your models in-house. So when you agree to the terms and conditions of some softwares, in the fine print it will actually take data from that software and use it to mine data so that they can sell products further down the road. If you want to keep your designs in-house, especially in aerospace and defense, it's a fantastic way to do so because checking the 3D print without STL files, you keep all of your information, you keep it proprietary, and you keep it in-house, which is a huge advantage. So I want to thank you very much. I'm more than happy to answer questions. You can type questions into the text box here if you'd like, or you can follow up. I'll bring up my slide here. You can follow up with me at any time. Feel free to reach out. My name is David Hayes again, and there's my email address, and feel free to send out some emails. If you have any follow-up questions or you name it, I'd be happy to jump on a phone call and have a conversation. Thank you very much for joining us, guys, and if I don't get any questions in the next 4 or 5 minutes, I'll log off. So we've got a great question so far in the question box. And what it says here is there any way to show what the support structure will look like? In SOLIDWORKS, right now, currently, it does not. However, what it will do is it will highlight the faces that the support structure will attach to. There's another software called GrabCAD Print, which is fantastic for that. And so what it does is GrabCAD Print is a new printing software that incorporates all of the Stratasys machines. It's in beta, but it's going to be released in November. And you can go ahead and download it from the GrabCAD website. I'll put it in the chat box here. Go ahead to grabcad.com and you'll be able to download the beta version of their print software. What it does is it will allow you to preview what the layers and the supports look like. It's a fantastic software. Here's just a little snippet of it. And the best part is it takes native CAD files from SOLIDWORKS and it's your print software. There's no more intermediary steps. So here, I believe the question is, how can we check the voids? And if I'm reading this correctly, I'm guessing it's going to be the gap detection. And so what it will do is, if you were to have an assembly fixture, that gap analysis tool will also tell you what your minimum gap is allowed to be. So if I go over into the preview, and here's my gap, it's a thickness and a gap detection. So if I want to detect for 0.2 millimeters of clearance on my assembly fixtures, which is our recommended suggestion from our 3D printing training course we provide at Javelin, I would go ahead and put 0.2 and I would calculate, and it looks like there are some thin walls but there are no gaps in this model, but what would happen is you would get blue arrows rather than these gold arrows. Great question about the 3D printer's capabilities and the compatibility. As of right now, if you have it into your network, you should be able to locate the IP address and connect to a printer. However, it's not designed to print directly from SOLIDWORKS. That's not the intent of this. The intent is really to do design verification and print checks before you print from your printer software itself. Great question in the question box here. So it says, how is SOLIDWORKS making toolpaths without converting to STL files? There's a little bit of discrepancy here, and it's not actually making toolpaths. So what it will do, it will predict the infill, but it won't actually draw out the toolpaths. So SOLIDWORKS inherently knows the volume of this feature, and by doing the infill percentage, it's just a mathematical equation saying that I want to infill this component by 40%. And so what it will then do is it'll then just hypothetically honeycomb this component by 40% or up to 40%, but it won't actually draw the toolpaths internally. It's not there yet, because what we're trying to do is we're not trying to change the toolpaths in this software. We would have to go ahead and use the software like Insight from our Fortis machines to go and change those toolpaths. But what you're seeing here, which is probably why it's easy to get confused, is the layer lines. So the software isn't making the toolpaths, it's just showing you what the layer lines will look like. So there's no data in behind the scenes of how the material will be deposited on the surface here. Okay guys, thank you very much for joining. Oh, I think we've got one more. Thanks. We've got one more question I'll answer quickly. Let's see. Well, I think we should follow up some follow-up questions via email. So feel free to email me the questions that you've seen here. And thank you very much for joining. Feel free to call me or email me at any time. Thank you very much, guys. Take care.